Good morning friends. In thermodynamics already we discussed about the thermal equilibrium. Thermal equilibrium, that means if the two systems are kept in thermal contact with each other, at that time the amount of the heat is flowing from one system to the another system. The system which is at higher temperature and other system is at lower temperature. So amount of the heat is flowing from higher to the lower temperature. This flow of the heat takes place till the temperature of the both system becomes the equal. That means due to the flow of the heat, the temperature of the system which is at high temperature decreases, while the system which is at initially low temperature, so temperature of this system is going to increase. After some time, the temperature of the both system becomes the equal. When the temperature of the both system becomes the equal, so in this situation, the exchange of the heat between the two systems is stopped. That means the both systems are in thermal equilibrium. Both are in thermal equilibrium. Now, in thermal equilibrium state, the temperature of the both systems becomes the same, and also the amount of the heat of the both systems are also same. So these two systems are said to be in thermal equilibrium. Okay. On the base of this, we are going to discuss about the Geodes Law of Thermodynamics. So we have the experience to know that the given water or the tea is how much hot or how much cold. So how we know it? At the time we are hold this cup of the tea or the glass of water. So with help of our skin, we can know it how much the given quantity or the given substance is hot or cold. But in our daily life, we are not using the thermometer to know the coldness or the hotness of a given body. By just touching that body, we can know that how much that is the hot or the cold. Okay. Now, to know the given body is in thermal equilibrium or not, we have to use the third body, that is known as the thermometer. If the temperature of the given body is same as the temperature of the thermometer or the temperature of the environment, both temperatures are same, so we can say that the given body is in thermal equilibrium. Clear this? Okay. Now, on the base of this, there is the Geodes Law of Thermodynamics. Now, the question is that explain instead the Geodes Law of Thermodynamics. There is also important question for the 2 marks. Very easy. Only we have to describe the figure. Now, listen. To know a system is in thermal equilibrium with its surrounding or not, a third body or the system can be used. Again, to know a given system is in thermal equilibrium with its surrounding or not, a third body, that means the system can be used. For that purpose, here we consider the three systems. System 1 and system A and B, first separated by the adiabatic wall. Adiabatic wall is the non-conducting wall. And the third system C is now in contact with the system A and B with diathermic wall. Diathermic wall, that means there is the conducting wall. So in short, A and B are separated by the non-conducting wall, and while the C is separated with A and B by the conducting wall. Initially, the temperature of all these three systems are different. What's happened? If the A and B are separated by adiabatic wall and C is separated with A and B by the conducting wall, or that means the diathermic wall. So what's happened? Suppose initially we assume that the temperature of A is T1, temperature of B is T2, and there is the T3. Suppose the T1 is greater than T2 and greater than T3. That means the temperature of the C is much more compared to the A and B. So what's happened? Here there is the non-conducting wall, therefore exchange of the heat between the A and B does not take place. But here, the conducting wall between the A and C and also between the B and C. Therefore, the exchange of the heat take place between the A and C and also B and C. Here the temperature of the third body C is much more. Therefore, the heat flowing from C to B and also C to A. This flow of the heat take place till the temperature of the C and B and also C and A becomes the equal. So after the some time, these three systems A, B and C are at same temperature. That means all three systems are in thermal equilibrium. Clear? Here the diatomic wall, that means the conducting wall between the A and C and also B and C. Therefore the exchange of the heat between the C and B take place and also the exchange of the heat take place from C to A. Now keep in mind that heat energy always flowing from higher temperature to the lower temperature. Here the temperature of the C is much more. Therefore the heat flowing from C to B and also C to A. This flow of the heat takes place till the temperature of the C and E becomes equal and same as the C and B becomes the equal. So after the some time, all these three systems A, B and C are at the same temperature. Therefore the exchange of the heat now does not take place or the stop. When the temperature of these three systems becomes the equal, so we can say that these three systems are in thermal equilibrium. So here the A and B are not directly thermal equilibrium with each other. Here A is in thermal equilibrium with C. B is also in thermal equilibrium with C. So we can say that if A and B are in thermal equilibrium with the third body C, then A and B are also in thermal equilibrium. Again, if A is in thermal equilibrium with third body C and B is also in thermal equilibrium with third body C, so we can say that A and B are also in thermal equilibrium. Okay. Now in figure B, if the adiabatic wall, non-conducting wall, is replaced by the conducting wall between the A and B. And now, the diatonic wall, that means the conducting wall between the C with system A and B, is replaced by non-conducting wall. So what's happened? Only the thermal equilibrium is established between the A and B. Because the exchange of the heat takes place between the A and B, but exchange of the heat does not take place between the A and C and not between the C and B. Again, as shown in the figure B, as we replace the wall separated between the system A and B, adiabatic wall is replaced by the diatonic wall, that means the conducting wall. And the wall between third system C separated by the A and B, this diatonic wall, conducting wall, is replaced by the adiabatic wall, that means the non-conducting wall. So in this case, what's happened? The exchange of the heat takes place between the A and B. But the exchange of the heat between the A and C and B and C does not take place. Because due to the non-conducting wall. Non-conducting wall. That is the non-conducting wall. Therefore, after some time, the thermal equilibrium are established between the system A and B. But these two systems are not in thermal equilibrium with C. So here, the thermal equilibrium is established between the system A and B, but not A and B system are in thermal equilibrium with C. Because the exchange of the heat does not take place with C. Right? So that is the explanation of the Geodes Law of Thermodynamics. Again, to know a system is in thermal equilibrium with its surrounding or not, a third body or the system is used. Okay? Now, as shown in figure A, system A and B separated by an adiabatic wall. that means the non-conducting wall. And both of them, these two systems A and B, are in contact with third system separated by diatomic wall, that is the conducting wall. This wall device is covered by insulated wall. These wall devices are covered by insulated wall. Therefore, the effect of the temperature does not take place. Okay. Now, the state of the system not being changed until the system A and B obtain the thermal equilibrium. The state of the system does not change till the A and B not obtain the thermal equilibrium with the third body C. When the A and B system obtain the thermal equilibrium with the C, therefore the state of all these three systems becomes the equal. Already we discussed A and C and B and C are in thermal contact with C due to the conducting wall, while the A and B not directly in thermal contact. Because this A system A and B are separated by the adiabatic non-conducting wall. So due to that, the exchange of the heat not directly take place between the A and B. So first, here the thermal equilibrium established between the A and C and also B and C. Then we can indirectly say that A and B are in thermal equilibrium with C. Then the A and B are in thermal equilibrium with each other. Again, let's shown in figure, system A and B separated by an adiabatic wall, non-conducting wall. And both of them, both the system are in contact with the third system C separated by diatomic wall, that means the conducting wall. And wall device are covered by insulating wall. Now, the state of the system A, B, C does not change or not being changed until the system A and B obtain the thermal equilibrium with C. What are the state? Thermodynamic state P, V, T, pressure, volume, temperature, and also the internal energy and amount of the heat are not changed until the A and B attain the thermal equilibrium with C. Now, after doing this, suppose the adiabatic wall between the A and B is replaced by diatomic or the conducting wall, and while the C is insulated from A and B by adiabatic wall. And whatever the wall diatomic between the system A, B and C is replaced by the adiabatic wall. Now the C is insulated from system A and B. Right? Then the state of the system of A and B being not changed means they are in thermal equilibrium to each other, and this is the base of the Geodes Law of Thermodynamics. Here, the A and B are in thermal equilibrium with each other, but not with C. So that is the base of Geodes Law of Thermodynamics. Now, what is the statement of Geodes Law of Thermodynamics? The system in thermal equilibrium with the third system separated are in thermal equilibrium with each other. So what it says that the system in thermal equilibrium with the third body or the third system. So we can say that this system are in thermal equilibrium with each other. Again, if the system A and B are in thermal equilibrium with C, then A and B are in thermal equilibrium with each other. That is the statement of Geodes Law of Thermodynamics. Or in other words, if the two systems are in thermal equilibrium with the third body of the system, then these two bodies are in thermal equilibrium with each other. That is the statement of Geodes Law of Thermodynamics. Now, the Geodes Law suggested that when the two systems A and B are in thermal equilibrium, there must be a physical quantity that has the same value for both systems. So how we say that the both are in thermal equilibrium? At that time, the one physical quantity, there must be a physical quantity that has the same value for both systems, and this quantity is known as the temperature. This quantity is known as temperature. Again, the Geodes law suggested that when the two systems A and B are in thermal equilibrium, there must be a physical quantity that has the same value for both systems. And this physical quantity is known as the temperature. So in short, if the A and B both are in thermal equilibrium, at that time, the physical quantity known as the temperature has the same value for system A and B. If the system A and B has the same temperature, we can say that these two systems are in thermal equilibrium. Clear? Okay. So that is the Geodes law of thermodynamics. Where is it? Only we have to explain the figure. Initially, there is the non-conducting wall, there is the conducting wall. Therefore, first thermal equilibrium established between the A and C and also C and B. So after the some time A, B, C are in thermal equilibrium with each other. So we can say that if the two systems A and B are in thermal equilibrium with the third body C, so we can say that these two systems A and B are in thermal equilibrium with each other. Now, we replace the adiabatic, that means the non-conducting wall between the A and B, by the conducting wall, that means the diathermic wall. And the wall between the system C and system AB, diathermic wall, is replaced by the adiabatic wall, that means the non-conducting wall. So here what's happened? The exchange of the heat take place between the A and B, but not take place between the A and C and between B and C due to the non-conducting or the adiabatic wall. So as a result, so after the some time, due to the exchange of the heat between the A and B, thermal equilibrium established between the A and C, but not with C. But not with C. But here in figure A, the thermal equilibrium established with all these three systems. But here, not established between the three systems, but only the thermal equilibrium established between the A and B. Clear it? Okay. On the base of the statement is that the system in thermal equilibrium with a third system separately are in thermal equilibrium with each other. So what it says that if the two systems A and B are in thermal equilibrium with the third system, so we can say that these two systems are in thermal equilibrium with each other. So that is the statement of Geodes law of thermodynamics. So Geodes law of thermodynamics suggested that when the two systems A and B are in thermal equilibrium, so there must be a physical quantity has the same value for both systems, and this physical quantity is known as the temperature. Therefore, the two systems are in thermal equilibrium, therefore the temperature of these two systems are same. Okay. Now after that, write the concept of the temperature from Geodes law of thermodynamics. What is the concept of the temperature? Now, the Geodes law of thermodynamics leads us to the concept of temperature. Again, the Geodes law of thermodynamics leads us to the concept of temperature. Temperature is marker of the hotness of a body. By knowing the temperature, we can judge about the body how much that is the hot or how much it is cold. Right? So temperature is the marker of the hotness of a body. It determines the direction of flow of heat when the two bodies are placed in thermal contact. From the physical temperature, when the two bodies are in thermal contact with each other, we can judge about that the amount of the heat flowing from which body to which body. The heat energy is always flowing from higher temperature to the low temperature. Suppose the two bodies A and B are kept in thermal contact with each other, A and B. A has the low temperature, less temperature, here the high temperature. So amount of the heat is flowing from B to A. Amount of the heat Q is flowing from B to A because the B is at high temperature and system A is at low temperature. So heat flows from the body at higher temperature to the one at lower temperature. So keep in mind that the heat energy always flowing from the body kept at high temperature to one is at low temperature. The flow stops when the temperature of two bodies is equalized, and then the two bodies are in thermal equilibrium. So exchange of the heat between the two bodies take place till the temperature of the both body becomes the equal. When the temperature of the both system or the body becomes equal, at that time the exchange of the heat take place becomes the zero, but the exchange of the heat is stopped. So in this situation we can say that these two bodies are in thermal equilibrium with each other. Clear this? Okay. So that is the concept of temperature from Geodes Law of Thermodynamics. Again, Geodes Law of Thermodynamics leads us the concept of temperature. What is the temperature? Temperature is the marker of the hotness of a body. So from the temperature we can know that the given body of the system is how much hot. How much hot. It determines the direction of flow. From the temperature we can also know about that the flow of the heat takes place from which body to the which. The heat flows from the body at higher temperature to the another one at lower temperature. Heat is always flowing from the higher temperature to the low temperature. So from the flow of the heat we can know that the which body is at the higher temperature or which body is at low temperature, or from the temperature of the body we can know that the direction of flow of heat. The flow stops when the temperature of the both body becomes the same or the equalized. Right? And we can say that these two bodies are in thermal equilibrium with each other. Clear? So that is the Geodes Law of Thermodynamics and also the concept of temperature.